All right, today we are going to start a process called linear programming. And up until now, I have taught you guys all of the skills that you should have in order to do this. And so what we're going to do today is come up with our own inequalities, our own equations. We're going to graph them, we're going to shade, and then we're going to do something one extra step beyond that. So you need to have your graphing calculators out, you need to have a straight edge out, you need to have preferably a pencil because of course you may make a mistake from here from time to time. So, alright. The first thing that you need to do when you're presented with a problem like this is you got to read everything through. So it says that the receptionist at a veterinary office is given the task of scheduling appointments. Each routine office visit takes approximately 20 minutes and a surgery takes 40 minutes. The office has 7 hours, 420 minutes available for appointments. The veterinarian will also not perform more than 6 surgeries per day. That's a lot of information. There's a lot of words in that problem, and sometimes that can be really scary. But what we're going to do today is try to break this down so it's not so overwhelming to you. The hardest part about these is going to be coming up with your inequalities at the beginning of the problem. So the first thing that the question asks you is this. It says to you, what does an x represent? So not always, but oftentimes when it will ask you what an x represents, you need to just look at your x-axis. Look down at your x-axis. What is on your x-axis? It says office visits. That's an x. So you write down here that an x represents an office visit. We're talking about a veterinarian. A veterinarian performs surgeries, and they have office visits. What about a y? What does a y represent? Look at your y-axis. It represents surgeries. Now, a veterinary office, a veterinarian may love what he or she does, but ultimately the veterinarian is doing that for a reason. What is the reason that they're being a vet? Yes, to make money, exactly. They want to make money. So yes, he will do all these great things for your animals, but ultimately the veterinarian wants to make money. That is what we're trying to figure out here. How can we maximize the amount of money that the vet will make? So this is what we need to do. We need to come up with an objective function. And that means what we need to do is write an equation or an equation that will get us to our goal. And our goal is to make money, correct? And we're going to make money off of performing surgeries and holding office visits. There is a sentence right here, probably the most important sentence, is it tells you how much money the vet can make. How much money will the vet make off of an office visit? He will make $55. An office visit will cost $55. So every time he has an office visit, he's going to make $55. So the objective function here is 55, that is a 55, not an SS, 55 times x. Why? Why do I have 55x?
Because it can be multiple, not just one.
Yeah, that x means I could have one office visit, I could have 2, I could have 10, I could have 25. It depends. Okay, so we have 55x plus, how else are we going to make money?
125x?
Yeah, 125
Y.
off of a surgery, which is we know surgeries are y. So we have 55x plus 125y. This is our objective function. This is what's going to help us meet our goal. So we will talk about that later. Put that aside in your brain for just a second. What we need to do now is move on to these constraints. And when I say constraints, what I really mean is inequalities. We need to come up with any issues that are going on with these office visits and surgeries. Because it said in there that he can only perform so many surgeries in a day, and he also only has a certain amount of time available to him to do this stuff during the day. So let's talk about time. It says constraints, time. We need to write a time constraint. So what I need you to do is go back to your problem, and everywhere that you see something in there about minutes, I want you to underline it. Wherever you see the word minutes, underline it. So, go back to here, I've got 20 minutes. Are you with me here? I underline it. I have 40 minutes. I underline it. And then it also says something about 7 hours, which is the same thing as what?
420 minutes.
420 minutes. So I'm going to underline that too. And I believe, if I've read correctly, that's the only time that they mention time. Okay? We need to combine all of that information and make it one inequality. So, we're talking X's and Y's. How many minutes does it take to perform an X? What is an X, you guys? It's an office visit. How much time does it take for an office visit?
20.
20 minutes. So watch what I do. 20 times X. 20X. But we also are going to perform surgeries. How much time does it take for a surgery?
40.
40. So I'm going to do plus 40
Y.
plus 40Y. How much time do I have available to me?
Is less than or equal to 420 minutes.
I have 420 minutes available to me. Do I have to use all 420 minutes?
No,
No.
so
No.
be less than or equal to.
Less than or equal to 420 minutes. So we do less than or equal to 420. That's all we can do with time. But we have another constraint we need to write, and that constraint is about surgeries only. So surgeries, read it. What does it say about surgeries? It gives you one little piece of information.
No more than 6.
Does that have anything to do with an office visit? No, it's called a surgery. It has nothing to do with an office visit. We cannot perform more than 6 surgeries in a day. So this is a little bit awkward, but all we need to do for this one is say the number of Y's that we perform in a day has to be less than or equal to what? To 6. There's no X in that one. Now, when you get to the second problem today, don't assume that you're going to have an equation or an inequality that only has a Y in it, okay? This just happened, for this time, that's what happened. But it doesn't mean it's always going to be like that, okay? All right, the hard work is done. Now it's just a matter of graphing things. So what we need to do now is take all the information that we had up until now, and we need to apply it to this situation. So you need to have your calculators out, you need to have your rulers out, your pencils ready, do some shading. So let's talk about this first. I'm going to talk about this one first. I'm not going to talk about the second one first. Y is less than or equal to 6. Y is less than or equal to 6. What kind of a line do you have? And don't say straight. Be more specific.
Diagonal.
Sheraylen. Horizontal. Yeah, have a horizontal line at 6. Go ahead and draw that in right now. Is it going to be a dashed line or a solid line? A solid line. And I am running out of room here. You can't see what I'm doing, so I'm going to scroll. So I'm going to be relying on you guys to be feeding me this information because I'm not going to be able to see everything. Should have a horizontal line right here at 6. Make sure you're using your straight edge. Nice and straight, not like mine. All right, where do you shade in comparison to that line? You have to shade where? Below it. Yep, it says less than or equal to, so you shade lightly. Everything below that line. Thank you. Thank you. All right, now we're going to go back and deal with that other line. So wherever you've got some empty space on your paper there, you're going to need to solve for y in that second equation. So I'm going to switch colors here. And I'm going to do my math over here. And I think wasn't the other inequality 20x plus 40y? Am I right, you guys?
Yeah.
Is less than or equal to 420. We have to solve for y. Solve for y. What do I do first?
Minus 20.
Minus 20x. I'm going to subtract 20x. I'm going to subtract 20x from the 420. So I have 40y is less than or equal to 240 minus 20x. And then of course I have to divide by 40. So I'm going to have y is less than or equal to, divide this by 40. We're going to have 240 minus, what's the matter? Oh gosh, I transposed my numbers. My bad, thank you for the catch. 420, thank you guys. I'm going to start over here. So we've got y is less than or equal to 420 minus 20x, and then divide it by 40. Make sure when you type this in, I don't have any. Make sure when you type this in, you put the top in parentheses, separated by the bottom, and I need a couple points. So type it in and get me a couple of points. Now, you guys, I have always said you need 2 points to graph a line, and that is true. You only need 2 points, but the more points you plot, the more accurate your line's going to be. So if you want to plot maybe 3 or 4 instead, it probably would be helpful. So I'm going to ask for a few points. Does anybody have one for me right now? Go ahead, Kyle. What you got?
110.
1, 10. Is that what I heard? 1, 10. That's good. Could somebody get me a point right on the x-axis? In other words, get me a y value of 0.
20.
What'd you get?
20.
21. 21, 0. Does that fall on your table? It's a really good idea, you guys, to plot x-intercepts and y-intercepts. That's an x-intercept, 21, 0. That is a good point to plot. Can someone find for me the y-intercept?
10.4.
What'd you say?
10.4.
10.5?
Yeah.
Okay, that's ugly. I don't want that one.
That's
I thought it was going to be nicer than that. I know, you're right, I did. What else? Give me another point.
These are all ugly numbers.
What'd you say?
They're all ugly numbers.
They're all ugly numbers. Do you have parentheses around the top?
Mm-hmm.
It's not 2x, it's 13.
Oops.
All right, give me one more point. Chelsea, can you give me one?
I say 0, 21, the opposite reflects y on the
0, 21, I don't think is on there. What,
Oh,
x
wait,
is
no,
0?
not on the, never mind. Scratch that, I was looking.
Shirley, can you give me one more?
13, 4.
13, 4. Okay. Let's plot those 3 points. Plot those 3 points and then connect them. So 1, 10 is right here. What's the matter? 13, 4. I'm going to go over to 13. I'm going to go up to 4. There's another point. And then 21, 0 is right here. You're going to connect them, do the best job you can, because this is when it really becomes important to make sure you're graphing good lines. Connect them with a straight edge. Where do you shade?
Underneath.
Yeah, because it says less than or equal to. So you are going to shade underneath that line. So here we go, everything under that line. And now what you need to do is darken in the region. Darken in the region that is double shaded. So I'm going to pick another color. What shape does this look like, you guys? Oh God, alright.
Trapezoid.
A trapezoid, thank you. Yes, a trapezoid.
They just have checks. Large checks.
Alright, so you have this trapezoid looking thing. Sometimes your shapes that you'll create will be nice, sometimes they won't be nice. In this case, it's not bad. But what I need you guys to do now is locate and circle every corner of your trapezoid. Locate and circle every corner of your trapezoid. So here's a corner. We have another corner down here. We have another corner right here. And we have another corner right here. And what I would like you to do now is go through.
I think I went up too far.
Yep, you did. Yep, that's okay. Just use it out. Just, you know, maybe someone. Do you have highlighters or something with you? Didn't you have highlighters with you? Okay. Here, I'll get you one.
Oopsie.
All right. What I need you to do now is label every point. So what is this point, you guys? It is the point 0, 0. What about that corner? What point is that? 0, 6. What about this point? Wasn't it 21, 0? And then we have this point. And if you did a good job graphing, you're not going to have an issue reading that point. But if you did not do a good job of graphing, it might be hard to figure out what that point is. Sometimes even if you do a good job, it'll still be hard to figure out what point it is. Now, this is what I would like you, I know some of you probably already have it labeled, and I'm sure you're right, but what I would like you guys to do is this. I want you to press window on your calculator. Press window. And what I want you to do is set up the window on your calculator to match the window that you have here. So what is your smallest x value on your graph? It is a 0. What is your biggest x value? It is a 30. So put your x min at 0, put your x max at 30, and that will switch our y's. Look at your graph again. What is the smallest y value? What is your biggest y value? It is 20. So set your y min at 0, your y max at 20, and now you need to do this. We're trying to calculate this point of intersection. So what I need you guys to do is have both lines typed into your calculator. So put something in, can you grab it, Danny? Thank you. In y1 right now, if I'm not mistaken, you still have the one that's 420 minus 20x divided by 40. Go to y2. Go to y2 and type in the other line. Type in a 6 in y2. Go to y2, type in 6. Are you with me here? Graph it, press graph. Press graph. And do second trace 5. Enter, enter, enter to get the actual point. Sometimes you will have to, in fact, I want you doing this because I did happen to glance at a couple of your papers and I saw a couple of you don't have the right point. Second trace 5, enter, enter, enter. What do you get, you guys? 9, 6. Right on? 9, 6. All right. Those are going to be important to us in just a minute. Now, read at the bottom of the paper. It says this. List 2 feasible plans. Feasible plans are plans that will work. In other words, they are, that combination has less than or equal to 6 surgeries, and they fit within our 420-minute time that we have available to us. I want someone to give me a feasible plan. In other words, an X and a Y that will work.
4, 6.
4, 6. So if I go over to 4 and I go up to 6, I get a point right on that line. Does that work? Does this point work? It sits right on the solid line. Is that okay? Yeah, if it was a dashed line, then it wouldn't work. But solid, so it does. So
Okay.
4, 6 works. Give me another point that will work. Something not right on the border. 4, 4. I heard 4, 4. If I go over 4 and up 4, that means if I perform 4 office visits and 4 surgeries in a day, I could do that. I have enough time, and it doesn't exceed the 6 surgeries per day that I cannot exceed. Okay. Give me one point that doesn't work. I need 1 point that does not work. Ashley, can you give me one? 18 and what? Perfect. 18, if I go over 18 and I go up to 8, I'm talking about that point. Too high, it's not in my green region. So 18.8 would be a non-feasible point. Okay, look what it's asking me to do now. It wants me to maximize my profit. I need to find the greatest amount of profit. Remember earlier we wrote an equation and we labeled it as our goal, our objective function. Our goal of this problem is to make the most money. Well, I'm going to rewrite that equation. I believe it was 55x plus 125y.
Yep.
Yeah.
Okay, this is what you need to do. We're almost done, you guys. Hang in there. You're doing a great job. This is what you need to do. All of these corners have to be put into that objective function. These are the only places that are going to maximize your profit. And we have to figure out which of those corners will get us the most profit. So, this is what we're going to do.
Okay.
Let's start with 0, 6. So what I need you guys to do is put that 0 in for x and put your 6 in for y. So you're going to do 55 times 0 plus 125 times 6. So I replaced my x with 0, my y was 6. Do it on a blank screen. You're going to do 55 times 0 plus 125 times 6. Get an answer.
50.
$750. Agreed? $750. All right. So we've checked this point. Now what we need to do, should we check this point down here, 0, 0?
No.
Is that, no, it's not, you're not gonna make any money. If you don't do any surgeries and you don't do any office visits, you're not gonna make any money. Stupid point, don't check it. Don't waste your time. All right, but this point right here, 9, 6, you gotta check it. Is that gonna get you more money? Yeah, because you've checked 0, 6. Now you're checking that 0 is now a 9, so it's gonna make you more money. Let's do it. 55 times 9. I need you to get me an answer. 50, not 50.
245.
Wow, you guys are way ahead of me. 1,245. All right, so we checked this one.
And then 21 0 is 1155.
21, 0. I'm going to do 55 times 21 plus 125 times 0. And you guys said it was 1,155. Where's my most money?
Good.
9 6.
Yeah, 9, 6. Now, some people are going to ask me, is it always going to be this point? You know, no, because it's not always going to be that blue constraint that I wrote is not always going to be horizontal. It might slant up. So, no, or slant down. Don't assume that is always going to be the point that will get you the most money. Okay? So, here we go. This one gave us the most money. It's the point 9, 6. So you go down here, and it says blank office visits. How many office visits are we talking about? 9 office visits. How many surgeries are we talking?
6.
6. And how much money are we going to make?
1, 2.
$1,245.
That's a lot.